Morning, everybody. Thanks for coming along. It's a great turnout. It's awesome. As we mentioned, BuildAR was launched back in 2009, and our focus back then was making web creation available through the web. But what we've been really working on since then is how we can make the experience available through the web. So we don't need to actually use a browser to just create the content, but you can also experience the full AR experience inside the browser itself. And so the title before was Roadmap to WebAR. That's pretty short now because it's actually working. So we can show some demonstrable things towards the end. And it's a really interesting time because there's just so much going on and so much changing. We've been waiting for this for pretty much since 2009 to 2007, really effectively. And we're ready to make the next announcements. So today I'm going to talk about the augmented web and how it blends the web and the physical world together. So first, let me talk about support. Which browsers support these augmented web experiences? So these are the augmented web browsers. Basically, they support WebRTC, WebGL, and then a range of other, sensor-based functions around the gyro, compass, those sorts of things. But you put all those standards together, and they allow you to run this augmented experience. Hopefully, WWDC is on today. Apple are really the biggest slice of the market that's missing at the moment. And the Get User Media API, which allows you to access the camera and the microphone, that is now a candidate recommendation. So it's effectively a standard for the W3C. So we're hoping that Apple will now adopt that, and if not, come out in the September release of the iOS update, hopefully not too long after that. But the big question is, how big is this market really? Is it a market that you can really deliver content to? And that's the thing that interests us the most about this, is the ease of delivery. So let's look at so Ori's got the stated goal of 1 billion regular users of AR, and I think that's an awesome benchmark for us to aim for. And if we look at where the current proprietary AR browser apps are, we've got a long way to go. So these are the stats live from the Android Play Store. So this is only the Android slice. Obviously, it's maybe half the market depending on which slice you're looking at. But it's a really good indicator of the scale or ratio. So Janeo has about 500,000, Wikitude about 1 million, and Layer about 10 million. So they've obviously done the best OEM deal, great distribution. But still, we're talking about really tiny numbers. If you look at the augmented web browsers, when I first put this together, they were 14 times the addressable market of the others. But the thing is, that was a year ago. Right now, that's grown 4 times. So already, if you look at these browsers, there is 600 million of those right now that you can deliver this content to. So we're already, well over half our way towards Ori's goal. And if you compare this to the proprietary AR browsers, it's a significant market, and it's much, much easier to deliver to. People will just send you a link, you click on it, and the experience happens. So that's really the key point. When you're experiencing the web, I think you're all familiar with that web experience, especially through social media. The ability to just send a link, someone, you click on it and open it. That's one of the biggest benefits of the web. Tim Berners-Lee's biggest innovation really was the Ahref, the link. So that's the current web experience. And if you add that to the augmented web, really it's exactly the same thing, except the experience is more immersive and richer, but exactly the same delivery method. So our platform takes the web and delivers this sort of content on fixed displays. And I'll walk through the different contexts, because this is one of the really interesting things too. If you compare it to the other AR development environments, we can now do some things really, really trivially that are virtually impossible in these other toolkits. And if not impossible, just very, very challenging. We've spent a lot of time working with other toolkits, and there's some real challenges to building those. So the first context is a fixed display. Now, this is not just a desktop. This can be desktop or a laptop. It could be a kiosk or an installation. Basically, it means that the display itself is in a relatively fixed position, or there are no sensors to detect that. And then the other contrast is the mobile display. So not only does the display itself move, but we have the sensors to detect that orientation in space. So the combination of these two is really what has driven responsive web design and the difference between the mobile web and the traditional web market. But this is really responsive web design on acid. We have to push it much, much further. We have to adapt more to the different devices and the different contexts. And I think this is a real argument for adaptive over responsive. Responsive, depending on your definition and who you'd like to follow on different blogs, it's more around stretching and adjusting content to different display contexts. Whereas adaptive is really, working out the context that you're in and totally changing the code and the CSS and everything to really match that context. So one of the interesting things with these two contexts, both the fixed and the mobile, is you can view them in a mono or a stereo display mode, and it's very easy just to simply switch between the two. So on mobile experience with the augmented web now, you can start playing with an augmented experience and go, I really like that, so you put it into stereo mode, slip it into a mobile as a mask sort of carrier, like the Zeiss or GearVR or any of those sorts of things, and then just strap it to your head, and the exact same code, exact same content runs in that context. It's a really compelling experience. Another thing that we can do is to share the experience. So one of the challenges with creating and delivering AR is it's a very subjective and almost lonely experience inside AR. There's very few AR applications that do very good multi-user experiences. And there's also very little insight into what other people are seeing. Trying to even preview content that other people are seeing just to present has always been a bit of a challenge, but to do that in the experience context for the end users has been a massive challenge. With this, the web supports WebRTC, which is natively just streaming a video. Actually, let me step back for a second. So let me just talk through a couple of standards, and everybody put up their hands if they've heard of them. So WebGL. Yep, pretty much everyone's comfortable with WebGL. So it's the 3D delivery layer for the web. And WebRTC. So effectively it's the standards organisations, so W3C's and IETF's effort to standardise streaming media and data through the web. So it can be seen at the lowest level as kind of a video conferencing tool. So really, that sort of Skype experience, FaceTime experience. But it unlocks a whole lot of other things. It's allowed us to access the camera, access the microphone, and the combination of that and WebGL, which delivered typed arrays, meant that we could reach into those streams. So it's no longer just plonk a video on a page and we could play or stop or pause. Now we can reach in, grab each pixel, process them in real time, process them in on the GPU as well if we want, and really access the camera, access the environment. So one of the things that allows us to do is stream the user's experience, what they're seeing, to a remote display. So we do this a lot with teachers. They love to show their class what one specific student is experiencing or doing. And that's a really compelling experience, something that's quite hard to deliver in other AR environments. So what I'll do is I'd like to show a demo video. So this starts with just the standard GeoAR experience. This is just a quick demo that I've videoed yesterday, I think. We're releasing a whole range of different demos and case studies over the next few months. This one starts with the standard GeoAR experience from, that you would have initially seen in Layer and Wikitude and those sorts of things. But now we've adapted that, and this is the start of an integrated SLAM sort of context. So we've taken the key concepts from SLAM, which is localization and mapping. And we've created a coherent coordinate space, so one coordinate space for all the different tracking contexts. And this has then opened up a whole lot of opportunities for us. So I'll talk about the natural feature tracking and other things in a moment, but this is let me go through, oops, which one? There we go. So this is the normal, look around. It's all just compass-based, and you can just see floating objects around you. But once you start to interact with these, this puts it into what we call a walk-around mode. And you can now then actually physically walk around the object. So this adds like a different language that you can use for creating the content. And you can see these are really dynamic things. So on this example, when you tap the character, he shoots a ball at you, and you can fire the other direction as well. It's really easy to create these sorts of dynamic interactions, and you can see the rendering's really pretty smooth. This is from a screen recorder as well. This is just a standard Android device, but this experience is really easy to deliver now. And you'll see that thanks to all the great work with WebGL, the quality of the content is amazing. We haven't even started showing the examples of the different shaders and filmic effects and processing that we can add to this. But this allows us to really interact with these objects much more. And what we can do is we can have multiple users interacting with these objects in different places, but create a shared virtual space where they can each be aware of where the other one is in that space as well. So this is opening up a whole new range of options, and as you can see, that really is AR, and that is all just in a web browser. There's no other external technologies at all. Okay, but that really is just the start. So what we've been waiting for is for the augmented web as a platform to really be at a minimum viable state. And it's taken a while. It's you set a moonshot goal, and you have to wait a while for that to arrive. But it's pretty much here now. And now we're also, all of the groundwork that we've laid for the other developments is ready to start rolling out as well. So we're at the point where we can really, make this a reality. So one of the next things that we're delivering is natural feature tracking. So we've developed a new natural feature tracking model designed for the web context in JavaScript from the ground up. It uses the GPU for optimized processing, and it just runs in the web layer. It's going to be released as an open source library, just like all of our other tools have been. And it's performing pretty well. So we're not quite ready to release the production version of that to show people yet, but I'm really excited about the progress we've made and the impact that that's going to make. The other thing is depth sensing. So one of my roles is one of the editors of the depth sensing extension in a W3C standard. So I work with some of the other Intel guys, and this is Ningxin. He created this. It was also shown at the Web Symposium at the W3C event, celebration of the 20 years. Tim Berners-Lee actually said these demos were some of the most exciting things that he saw. They allowed you to play Fruit Ninja and those sorts of things, but using the depth sensors. So effectively, instead of just an RGB camera, it also adds a depth layer as well, so RGBD or depth only. And as you can see in this here, we're basically just taking the depth map and the image map and moving each of the pixels to the depth that the sensor's picking it up. So this is just a trivial example, but we can do a lot of processing. And when you combine this with our tracking model, the new one that we've created, that works in 2D and 3D. So this is just going to open up a whole other world. If you look at Tango devices, you can already do some of this with the Leap. That provides a WebSocket API, so you can just talk to it, grab the data, and then we do that a lot in education where people want to wear the displays, like the mobile as a mask sort of display, but be able to stand in front of other objects and use sensors to detect their hands. You can even strap it to your head as well. So yeah, depth sensing is going to have a massive impact. So we're pretty much ready to launch the next generation of BuildAR. And if you'll see at the bottom, awe.org. So we launched the augmented web here back when it was ARE in 2012. And we're about ready to do this new launch of our product. And it's really rebranding as the augmented web experience. So I'd encourage you to follow our Twitter account to find out more. We'll definitely be releasing a lot more examples. They'll include code as well. We're working with a lot of different people to create case studies for specific examples, because the main thing with all of these is you really need to see it and try it to understand it. But if there's one thing that you can take away from this, and I'd really like you to, is that delivering AR content can now be as simple as just sharing a web link. If you look at the steps, I think I did another screen capture. Every now and then we take screen capture tests to see how many steps are involved to go from, I possibly know there's some sort of experience around me somewhere to actually experiencing it. And not to pick on them, but that was just one of the ones that I went through. If you go through the layer experience from, I'm aware that there's something in the environment to actually running it, it's 17 steps. You have to go through, find it in the App Store, download it, go through a first use experience, then search for your content again or scan again. So if you compare 17 steps to 1 or 2, it's a massive difference in terms of delivery. That's my presentation. So thank you very much. Are there any questions? Yeah, sure.
I'm relatively new at this, and the company that I work for was using another service vendor. And our goal was to build our own standalone app.
Yep.
Is that possible using?
Yeah, I mean, you can definitely wrap these things. So the XDK sort of discussion will be a bit about that. Our focus is on delivery just through the web platform. We do build a lot of native apps. I'm sorry, I'm not a big fan of them. They cost a lot to maintain and they're expensive to deliver. But other than that, I love them.
You do both.
Yeah, you can definitely do both. And we definitely encourage people to wrap them. And there are definitely contexts. The main real differentiators were things like notifications and push notifications, those sorts of things. But all those standards are now pretty much available in the web as well. So yeah, you can do that, but I definitely encourage you to look at just web-only delivery as well. Hi.
Hello.
Hey, hi.
Are you building your own nature feature tracking component? Or
Yeah. So it's.
Can you repeat the question into the
Oh
microphone?
yeah, sorry. So the question was, are we building our own natural feature tracking system? So yeah, it's called Tiger's Tail, and it's based on the fast feature detector, but a different approach to that. And yeah, so yeah, we have built a new one from scratch.
what is that called?
Tiger's Tail. Yeah. Yeah.
Does it include 3D object tracking as well?
Does that include 3D object tracking was the question. Yes, so the model definitely does, and we're doing work with that on the depth sensing context. The first one that we'll release will be 2D only, but the model does work for 3D context as well.
Facial recognition or not?
Yeah, that's, you can already do, in fact, you can already do that really well. So you can do that with HAR wavelet type tracking. Those libraries, I can show you some great examples that just run in the web browser already. But then, yes, with the 3D tracking, we could easily add topologies like faces and things.
Yeah, I wanted to ask you, is this going to make it so that like this SDK can work with this SDK? Everybody's got separate things. I was waiting for a platform where they all kind of talk to each other.
Yeah.
So where they can kind of interact with each other on a general
Yep.
platform. Is it going to do that?
So the question was, will this solve the broad interoperability problems? No. So what this is this is just the modern version of the web. So we're not trying to backport to these proprietary platforms. What we're saying is there's an existing platform there with over 600 million users and by the end of next year projected to be over 2 billion. And that's just a viable market in itself, and it's already based on open standards. So we've been involved in the AR standards developments for a long time, but to us it seems like there's already a platform there, and it's a lot of work to recreate the interoperability.
What's your depth sensing? How deep can you sense depth?
So that depends on the sensor itself. At the moment, so we're looking at using 16-bit values, which gives you about 65 meters. But at the GPU Tech conference, there was some guys showing some interesting LiDAR stuff that was possibly indoor, but could have longer ranges than that as well. So, hi.
For the depth sensing, are you using OpenAI or have you rewritten that?
No. So the question was, are we using OpenAI for the depth sensing? So it's technology agnostic. So the sensor vendors will create their sort of layer that, and they already provide the SDKs, those sorts of things. So RealSense and the Kinect and those sorts of things, you can just plug them in, and the web browser layer does all of that interconnect, and then you have a standard API above that, so you don't have to worry about lower level things. But it is raw depth sense data. Yeah. Oh, yeah, one more.
You have plans for like a user community of AR experiences
Yeah.
where people can share their versions of reality and
Yeah, so one of the big parts of our new model is it's going to be much more like GitHub, so you can fork people's projects if they're open projects. And the idea is to really create that fostering of community. One of the really cool things about the web is view source. That's how I learned to program effectively. And that's something that we really want to encourage, being able to, share your source like that in an open way. Obviously, people may or may not want to do that, but with the web, that content's viewable anyway. So, yeah, great question. Thanks. Thank you very much for your time. I think that was a little bit quick. But
Thank you, Rob.